Okay guys, so section 4.2, notice we are still solving systems of linear equations, but now we are on method 2. Last video we talked about solving systems of linear equations by graphing. That was method 1. Method 2 is by substitution. We've substituted things for a while, guys, and we're going to still think about it in that way. It just gets a little bit more complicated, but just know you've substituted many times before. It's the same idea. We've just got some more numbers going on. We can do it, okay? The substitution method is a method of solving a system by substituting an expression. So we're substituting like two terms, a whole expression in for a variable. So a lot of times we would just substitute a number in for a variable. Now we're substituting in an expression. Guys, an expression is like this. X plus 3 is an expression, okay? For a variable leading to a one variable equation. Note, it is best to use this method when the coefficient of x or the coefficient of y is 1. Having a coefficient, remember this is a coefficient of 1, this would be a coefficient of 2. Okay, having a coefficient of 1 is going to make it a lot easier to substitute. I'll write that a little bit better. So let's take a look at some steps. The first step we need to do is solve one of the equations for a variable, either x or y. So we need to, and I want to also write, get one variable alone. Okay, so we needed to say x equals something or y equals something. Then we're going to substitute the expression. This is the expression we're talking about. This part is the expression from step 1 into the other equation and solve for the variable. And then we're going to substitute again, it's crazy, the value from step 2 into the either original equation to find the value of the other variable. It sounds like a lot. We'll be okay. Okay? So let's check out problem 1 here. The first step says solve one of the equations for a variable. We need to have either x equals or y equals. Notice for problem A, well, this is cool. I already have one variable isolated, right? That y is already by itself. So what happens, I'm going to take this expression, this part of the problem, 2x minus 4, and substitute it for y because it equals y in the other equation. Okay, so watch me very carefully. In that other equation, I'm going to have 7x minus 2, but instead of y, I'm going to have the expression in the box here, 2x minus 4 equals 5. See how I substitute, and this takes a little bit. I know 2x minus 4 equals y. So I'm going to substitute it in for y in the other equation. See how this says 7x minus 2y equals 5? 7x minus 2y, this whole thing is y, equals 5. And then we're just going to, that was step 2, now substitute the expression. And now we're going to solve the only variable in this equation is x. So we're going to solve it for x. We're going to do some distributing. 7x, we have to do minus 4x, we distribute, and then distribute again here, plus 8 equals 5. Combine like terms here, that gives me 3x plus 8 equals 5. Subtract 8. Divide by 3. Now I have one of my answers. Remember in the last section, we talked about how a solution is x comma y. So all we have right now is x is negative 1. I still need to find out what y is. So I'm going to go back to my first equation. I know this equation, y equals 2x minus 4. They gave me that in the red box right here. So in order for me to figure out what this y is, I still need to know it. I'm going to substitute the x into this equation that I just found. Y equals 2 times negative 1 minus 4. y equals 2 times -1 is -2 minus 4. -2 minus 4 is -6. This is my solution. Okay, let's check out another one. First step, get one of the variables alone. Notice both of the variables are alone. It says y equals 2x plus 3, and then my other one says y equals 5x. So if they both equal y, then these both equal each other. One equation, one variable that we get to solve for. I'm going to combine like terms. Solve for that x. So now I know x equals 1. I still need to find the y. I can pick either of these equations. It doesn't matter. This one might be easier, right? So I'm going to do y equals 5 times x. Well, now I know x is 1. So 5 times 1 gives me 5. Okay. And then problem C. We need to get one variable by itself. Notice this variable is already by itself. I know x equals 5y plus 3. So I'm going to take 5y plus 3 and substitute it in for x in the other equation. So I'm going to have 2 times, I now know x is 5y plus 3 plus 4y equals -1. See how in for this x, I substituted in 5y plus 3. The 4y is still there, the -1 is still there. One equation, one variable to solve for. Distribute the 2. Combine like terms. Subtract the 6 over. Divide by 14. Y equals -1/2. So here's my solution so far. I know the y value, I still need to know the x value. Okay, so I'm going to come back to my equation. Okay, well I know x equals, I'm going to do it up here, I know x equals 5 times y now is -1/2 plus 3. X equals, multiply fractions, we go straight across, plus 3. I need a common denominator. That's going to be 6 over 2. 6 over 2 is the same thing as 3. This equals 1/2. Okay, that's my solution. So let's practice now on this next page. We may need to do some rearranging to isolate that one variable. So these take a little bit longer. So if you look at A, notice there isn't an equation where the variable is already by itself. Okay, so I need to pick one of those variables that has a coefficient of 1. Coefficient of 1 means the number right in front of the variable is a 1, or it's not there. What I'm looking at is right here, this x. That has a coefficient of 1. The next one has a coefficient of 4. This one has a coefficient of 3. This one has a coefficient of 7. Having a coefficient of 1 is easier. So then I'm going to take this equation and get that x by itself. So I'm going to subtract the 4y over. And so now I have x equals 14 minus 4y. And now I've got the variable by itself. So now pretend that my system was x equals 14 minus 4y and 3x plus 7y equals 22. Guys, all we did was rearrange an equation, because now it's just like problem 1 that we did on the previous page. Now I'm going to take what I know x equals 14 minus 4y and substitute it in for x. So I'm going to have in the other equation, I'm going to have 3 times 14 minus 4y plus 7y equals 22. Let's distribute the 3. So I'm going to have 42 minus 12y plus 7y equals 22. I'm going to have 42 combine some like terms here. Negative 12y plus 7 is negative 5y equals 22. subtract the 42 over. Negative 5y equals negative 20. Divide by negative 5, y equals 4. Is part of my solution. All we do is come back over to the other equation where x is already alone, right? This guy right here. I'm going to have x equals 14 minus 4 times 4. Substitute what I know y in for. X equals 14 minus 16 equals negative 2. Okay? Just an extra step of rearranging one of those equations at the beginning. Let's check out B. So again, one of the equations doesn't have the variable isolated. So I pick, it doesn't matter, notice B already has the coefficients of y and x are both 1. So I can just pick one. I'm just going to add that x over. So it says y equals x. Okay? Now I'm going to say, and it doesn't matter, because I know y equals x, I'm going to substitute x in for y. So I'll have 2x minus 5x equals 9. 2x minus 5x gives me negative 3x equals 9. Divide by negative 3, x equals negative 3. I just need to find the y. Well, wait a second. Y equals negative 3. Okay, good job, guys. And this is the last, I'm going to talk about problem 3 in a little bit. So great job so far on learning how to solve linear equations by substitution. Great work.